Welcome to this video about pharmacogenomic tests. My name is Rachel Huddart and I'm a scientific curator at the Pharmacogenomics Knowledge Base, or PharmGKB. In this short video, we'll go over 3 important questions to ask of any pharmacogenomic test. These questions cover general features of pharmacogenomic tests that should be considered either when selecting a test or when looking at test results. PharmGKB does not offer any advice on the advantages or disadvantages of specific pharmacogenomic tests. Let's start with our first question. What alleles are included on the test? Test results for many genes which are important in pharmacogenomics may be reported back as star alleles. Each star allele defines a particular combination of one or more genetic variants that are found together. To learn more about star alleles, watch our haplotypes video. Pharmacogenomic tests tend to only cover the most commonly found star alleles, meaning that rare alleles are unlikely to be detected. On top of this, different tests may test for different star alleles. If we were to look at the gene CYP2C9, for example, one test may cover the star 2, star 3, star 5, star 8 and star 11 alleles, while another may only include star 2 and star 3. The Association of Molecular Pathology is working to standardize the minimum set of alleles that should be included on pharmacogenomic tests. A link to their resources is given in the description below this video. If a pharmacogenomic test doesn't find any variants in a particular gene, it will assign the star 1 allele by default. Star 1 is thought of as the reference allele for most genes important in pharmacogenomics. However, assigning star 1 to a patient doesn't necessarily mean that that patient has the star 1 allele. They may still have variants which aren't detected by the test, and those undetected variants could still affect protein function and the patient's response to a drug. Now that we've looked at which star alleles are covered by a test, we should also check how the test identifies those star alleles. Some tests will use the presence of a single variant to identify a star allele that might contain multiple variants. A common example is the star 10 allele of the gene CYP2D6, which is typically identified using a variant called 100C-T. However, the 100C-T variant is found in many other CYP2D6 alleles, some of which have different function assignments compared to the star 10 allele. If a test finds that someone has this 100C-T variant but none of these other variants were tested for, the test will report that person as having a star 10 allele, which may not actually be correct. It's also important to find out if test results will be updated as new evidence becomes available. There's a perception that pharmacogenomic test results are for life, because your genetic variants won't change over the course of your life. This idea isn't actually accurate. We're learning more and more about pharmacogenomics all the time. New star alleles can be found, or occasionally existing star alleles might change or be assigned a different function. New relationships between genetic variants and drugs can be found, and new pharmacogenomic guidelines are regularly published. Ideally, pharmacogenomic test results should be able to be updated as new evidence and guidelines become available. A bonus question just before we finish. Pharmacogenomic test results may not explain why someone isn't responding well to a drug. This could be for a number of reasons, including some of the points covered earlier in this video. Pharmacogenomic tests only cover the pharmacogenomic relationships which are supported by a significant amount of evidence. There are many other relationships which have been uncovered by researchers. PharmGKB has information on over 4,500 and counting. More evidence is needed to confirm many of these relationships so they can be included on tests. It's also likely that a person's response to a drug is the result of the combined small effects of variants in different genes rather than a single variant with a large effect. Research is starting to uncover these smaller effects, but more work is needed until we understand them enough to use them to guide drug prescribing. Finally, it may not be the person's genetics which is causing the poor drug response. Factors like diet, other health conditions, and other medications can also have an effect. These are the 3 questions you should ask of any pharmacogenomic test. What alleles are included, how are they identified, and will the results be updated as new information comes to light? The Association of Molecular Pathology, PharmVar, and the Genetic Test Registry all have excellent resources which can help you understand some of the complexities of pharmacogenomic tests. Links to all of these are in the description below this video.